Plastics. Materials can come in two types. There are natural materials, wool, leather, silk, cotton, all organic in some form or other, or synthetic. Most synthetic materials that we have in this country or in this world are made from a crude oil starting product, generally naphtha. This gives us plastics. There are two types of plastics. Thermoplastics, which can be reshaped easily on heating, and thermosetting plastics, which, due to cross-links between each polymer strand, remain hard even when heated. Think pan handles, which you do not want to go soft. These will eventually burn rather than melt. All plastics are what are termed polymers. A polymer is a strand made of many smaller units, a monomer. A monomer is just the name for a single unit of the polymers. The name for the polymer is always the name for the monomer with the term poly added to the front. In addition polymerization, a double bond will be present between two of the carbons. This is split, allowing more of the same monomer to be added either side. In the example given, we have vinyl chloride as the monomer, with the double bond split and other monomers added either side. The product becomes polyvinyl chloride, PVC. Always draw 3 of the repeating units. A polymer can be many thousands of these repeating units in length. A second type of polymerization, condensation polymerization, occurs when an ester is formed between the two repeating units, between the two monomers. Esters, as seen earlier, are formed when a carboxyl group loses its OH along with the H from a hydroxyl group to give us water coming away. You will be able to spot a polyester, as these are called, because there will be an oxygen present in the spine of the actual polymer. Occasionally, it is possible to have polymers, condensation polymers, from the being formed from amines. This is given at the bottom there. This will give us amino acids and proteins. The process is exactly the same. The OH from the carboxyl group, in this case, will react with a H from the amine group to give us water coming off again and the protein polymer. Fertilizers. Fertilizers are used due to the increase in population on the earth. We are now over 7 billion people present. This has doubled within inside the last 50 years, to allow us to feed this increasing population. One of the problems we often get with fertilizers is a process called eutrophication, whereby the fertilizer can be washed into river systems, which will cause pollution in the river systems, algae blooms and such things. Natural fertilizers, manure, have been used for thousands of years. This is all to do with adding nitrogen back into the soil. Nitrogen is needed for healthy plant growth, along with 2 other compounds, chemicals, potassium and phosphorus. This gives fertilizers what is called an NPK rating. In nature, leguminous plants, peas, beans and such, will take nitrogen from the atmosphere and be able to make it into soluble nitrogen compounds for the plants to use, along with animal manure, animal bodies and that sort of thing. Due to the number of humans around, humans need to look at using synthetic fertilizers. One of the processes used for making these is the Haber process. This is an industrial process for making a chemical called ammonia. Ammonia contains nitrogen and hydrogen, NH3. The process needs to be at a high temperature, about 500 degrees, and at a high pressure, about 250 atmospheres. This is due to the process being reversible. It goes both ways. As soon as some ammonia is made, it starts to dissociate and turn back into nitrogen and hydrogen. The temperature and pressure are controlled to give as high a yield as possible, and the process is a continuous one, with any unused nitrogen and hydrogen being fed back into the conversion vessel. The ammonia is then used in the Ostwald process to be converted into nitric acid through three steps. Ammonia plus oxygen, giving nitrogen monoxide and water. The nitrogen monoxide then reacted with more oxygen to give nitrogen dioxide, and then the nitrogen dioxide is used, reacted with water and oxygen to give the nitric acid. This is all done in the presence of a platinum catalyst. One thing to remember, in the Haber process, it is an iron catalyst. A question often asked is a percentage composition question, i.e. how much nitrogen is present in nitrogen phosphate. This is a simple calculation. The mass of nitrogen in the compound is divided by the mass of the entire compound and multiplied by 100%. In the example given, the mass of nitrogen is 3 nitrogen atoms, 42, divided by the total mass of ammonium phosphate, 149, times by 100 equals X. Nuclear chemistry. There are 3 types of radiation. Alpha. This is a large particle. It is best described as a helium nucleus with 2 protons and 2 neutrons to give a mass of 4. It is stopped by paper and doesn't travel very far, and it has a positive charge to it due to the 2 protons. There's beta radiation. This is a small particle. It's actually an electron. It is stopped by thin aluminium and has a negative charge. Also, there is gamma radiation. This is not a particle at all. This is an electromagnetic wave, much like light. It is stopped by thick lead and has no charge. If an element loses an alpha particle, it will fall by 2 at the bottom, the atomic number, and 4 for the atomic mass. If an element loses a beta particle, it will increase by 1 at the bottom. But stay the same for the atomic number, as the number of protons might have gone up by 1, but the number of neutrons has fallen by 1. Half-life. Half-life is the time for half the radioactive material to become non-radioactive material. Half-life for carbon-14, approximately 5,000 years. In 15,000 years, that would mean we would have 12.5% of the carbon material left, as it loses 50% each time. Chemical analysis. Chemical analysis involves looking at the idea of flame tests. These are in the data book, and they give the colours of ions, generally metal, as they appear in flames. Potassium being lilac, sodium being yellow, etc. Chromatography. This is where a soluble material is allowed to move up a stationary phase, i.e. colours moving up a piece of filter paper with the bottom of the filter paper in a small amount of water. The heavier the colour, the heavier the molecule that makes up the colour, the shorter the distance it travels. And then titrations. This is a method of looking at neutralization, using neutralization to find how much of what concentration of a material is there. Always ignore the rough titrate when working out an average. And the formula to use, as seen in the acid section, is acid volume times acid concentration times acid power, which is the number of H's present, will always equal the base volume times the base concentration times the base power.